Hello and welcome everyone. Our today's question is check for BST. So we have given a BST and we have to return if it is a valid BST, else false. So we have given a root node, so its left values must be smaller. So for 2 left values is smaller and on the right hand side all the values must be bigger. So it is check for 3 also, right hand side value is bigger. So return true. In this case, check for 2, the right side value is bigger. Check for 7, the right side value, all the value on the right hand side is not bigger. We have a smaller value, so we will return false. In this case, for 10, the left hand side value is smaller, the right hand side value is not bigger. We have a smaller value here, so we will return false. So this question has two very interesting approaches. I will tell you both of them. So we have this tree. So our first approach will be, if you traverse in order, then you have a sorted list if it is a BST. So while traversing in order means first left, then node, then right. So I am checking for root node. So all the values on the left hand side must be smaller. Then this value come into the play. Then all the values on the right hand side. So we will maintain a previous variable. Initially it has minus infinity. So we have a root node. So first we go left hand side, then left hand side, then left hand side is null, then node. So this value must be greater than all the values on the left hand side. So we have traversed all the values on the left hand side and we have value which means the previous value. So we have this value. So this value must be smaller than this value. So 4 must be greater because we have traversed the left hand side values, then this value comes. So this value must be greater than the previous value. Yes, it is. So assign this value. So I assigned 4. Then go to right hand side is null. No issue. Then we have 7. So I have traversed the 7 and we have previous value as 4. Okay. Then node means is 7. So 7 must be greater than 4. Yes, it is. So reassign your previous value. Now it is 7. Then go to right hand side. Then its left hand side is null. Then node. So this 9 must be greater than this 7. Yes, it is. Because we have first traversed the node, then we are going on the right hand side. So right hand side values must be greater than the previous value. So it is. So reassign your previous value. Now it is 9. Then go to right hand side. Right hand side is also null. Then this value node. So we have traversed the left hand side and the largest value on the left hand side is 9. So this value node, we have traversed the left, then node. So this node value must be greater than the previous values. So in this case it is. So we will assign our value to the previous variable. Now we have traversed first left side, then node. Now it's time for right hand side. The right hand side values must be greater than the previous value. So our previous value we have is 15. So then we are going right hand side. First go left hand side is null, then node. So this 16 must be greater than this. Yes, in this case, so we will assign our value. Now it is 16. Then we go right hand side. Left hand side is null, then node. So 19 must be greater than the node value. We are going then the right hand side. So this value must be greater than 16. Yes, it is. So reassign your value 19. Right hand side is null. So now this value. So we have traversed the left hand side. Now all the values on the left hand side must be smaller than the current node. In this case, it is not, means we have a bigger value on the left hand side. So this tree is not a BST. So we will return false. So that's it. It seems fascinating, but its code is very simple. So we have a global variable previous. So initially its value is minus infinity. So then we apply in order traversal, because in order traversal of a BST is a sorted order. So in order, if root is null, means it is a valid BST. Then we go to left hand side. If left hand side tree, I'm again saying, if left hand side tree is not a valid BST, then directly return false. If left hand side tree is not a valid BST, then directly return false. We don't have to go further. Then check for current value. We have a previous variable, so we have traversed the left hand side. So we have previous variable and root data. So root data must be greater than the left hand side values. So if it is not, means our previous variable is greater or equal. Previous variable is greater. Previous variable we have attained while going to left hand side. So if we have a larger value on the left hand side, so directly return false, or we have equal value. So in BST we have unique values. So BST cannot contain duplicate values. It is written here also. So if it have similar values or duplicate values, then directly return false. So we have traversed left hand side and node. So till now uh, we are good to go. Then only thing remain is right hand side. Then whatever result stored on the right hand side, just return the. So before that we have to reassign our previous value. So after that, just go to right hand side, and whether it will return true or false, so directly return that value. So let's submit this code, and it is working fine. Let's talk about the next approach. It is also very interesting approach. I talked this approach yesterday. So we have a root node, so its value must be between minus infinity and infinity. Then all the values on the left hand side must be smaller than 15, means the largest value we have is less than 15. So we are not including 15. So we have minimum value and maximum value. So it is a range of minimum and maximum. So all the values on the left hand side must be smaller than 15, and it is under the range of minus infinity and 15. So first check for the root node. Yes, it is between the range of this. Then go to left hand side. So we have a range minus infinity and 15. So the maximum value uh, we cannot have is 15. So then this node is fine. Then go to left hand side. Then all the values on the left hand side must be smaller than 7. The maximum value we can have is 7. We cannot have is 7. So we have this range. So this value is also fine. Then left and right is null. So for this node, let's go to right hand side. So the maximum value, so the minimum value we cannot have is 7. So all the values on the right hand side must be greater than 7. So I am repeating again, all the values on the right hand side must be greater than 7. So we have a minimum criteria 7. So we cannot have 7 or smaller than 7. So we have minimum value as 7 and maximum value as 15. So we have this range, and this value, this node is fulfilling our criteria. So this node is fine. Let's go to right hand side. While going to right hand side, all the values on the right hand side must be greater than 15. So we have a minimum criteria of 15. So 15 and infinity. So if this node is 15 or less than 15, means this is not a valid BST. So this node is fulfilling our criteria and under the range. So let's go to left hand side. So on the left hand side, all the values must be smaller than 17. So we have a maximum criteria of 17. So we cannot have 17, and our minimum criteria stays same, and our maximum criteria is 17. So this and this. So excluding 15 and excluding 17, because we cannot have duplicate values. So 17 and 15 is excluding, and the values must be under this range. So we have this value 16. So 16 is under the range of 15 and 17. So let's go to right hand side. So the right hand side values must be greater than 16. So our minimum criteria is 16 now, and our maximum criteria is 17. So our minimum, then node, so this is node value, then our maximum. So this must be valid. The value, node value must be under the range of minimum and maximum. If value is greater than or equal to minimum, means it is false, or our maximum is smaller than or equal to node value, so we have to return false. It is not a valid node. So in this case 19, so 19 is a value and our minimum value is 16. In this case it is false because it is greater than our minimum criteria. Actually I missed one thing. I made a mistake here. So our minimum value is greater. So here this must be true. So the value must be under this range. So if we inverse this, so we have minimum. If minimum is greater or our value is greater than maximum, so then we have a invalid node. So in this case our value is 19 and our minimum is 16. So in this case the value is greater than minimum value, so it is fulfilling our minimum criteria. But for maximum, the maximum is smaller than 19, means the value must be under the range of maximum also, but it is exceeding the maximum value, so we will return false. So let's code this. So its code is also very simple. We have a solve function and we are passing root and minimum and a maximum range. So for root node we have minus infinity and infinity value. So our root node must be in the range of minus infinity and infinity. So root, min and max. If root is null, simply return true. Or this condition, if this condition is false, means our root node must be greater than minimum. So if minimum is greater or our root is greater than maximum, means our root node must be smaller than maximum also. If it is not, if we have a or condition, or either this condition true or this condition true, then simply return false. Then our root node satisfy the range condition, then we have to go left hand side and right hand side and check for both, for all the nodes remaining. So we have a and condition, means so here we are going left hand side and our minimum criteria same, it stays same, and our maximum criteria now is root dot data. So our maximum criteria we have is root dot data. So all the values on the left hand side must be smaller than the current node. So then we have and condition, means left hand side and right hand side tree must also be BST. Then while going to right hand side, so we have root dot data is the minimum value, means while going to right hand side our minimum value must be greater than 15, uh, according to our example. Let's submit this. If you are watching till now, a click on the subscribe button is highly appreciated. And we have successfully solved this question again. Thank you all for watching this video.